So in this video, it's kind of a review of a topic that we covered in 7th grade on ratios and proportions. But we do add some new twists in here, or some new concepts, basically pushing it a little bit further. We're determining whether or not two ratios form a proportion, and we will solve different proportions. So a ratio is simply a comparison of two numbers by division. We can write it as, out in words, x to y. We might use a semicolon in the second version, or often we typically see ratios as a fraction. Okay. So this is comparing x to y in a fraction. A proportion, on the other hand, is an equation, so we have the equal sign, stating that two ratios are equal. And sometimes we're asked to test that to see, yes, in fact, they are equal, or no, they're not. In this example we have on the board, if we take a look at 4/5, if we multiply it by 6 over 6, and if we think about it, 6 over 6 is equal to 1. Any number times 1 is itself. So 4 times 6 is 24, 5 times 6 is 30. These two are equal. And we know at that point that it is a proportion. If they're not equal, then it's not a proportion. So typically when we're trying to decide if two ratios are a proportion, there's a couple things we can do. One, we can just use our skills and determine, is 2/5 indeed equal to 6/10? And see, is there something I can multiply them both by that gets us to the correct answer? And in this case, yes, there is. If it's a more complex fraction that maybe we don't see, it's not a common fraction, we can go ahead and divide. So if we took 1 divided by 6, and I'll rewrite that out as a number sentence, 1 divided by 6, when I use that, we find that it is equal to 0.16 repeating. The 6 is repeating. 5 divided by 30, if I enter that into a calculator, will give us the same answer. If the decimals are the same, and I put them into a calculator if need be, or just divide it longhand. If the decimals are the same, the two are equivalent. So that's another way to look at it. Looking at number 2 here, if we use cross products, so is 0.04 over 0.8 equal to 0.7 over 1.4? We can go ahead and multiply across and go 0.8 times 0.7 and find out, is that equal to 0.4 times 1.4? And again, some of us might see right away that 0.4 over 0.8 is equal to 1/2 or 0.5, as is the other side. So some of us have already seen these are equal. If not, we can go ahead and try 0.8 times 0.7. That gives us 0.56. And the other one, 1.4 times 0.4, is also going to give us 0.56. So if the left side and the right side are equal, we have a proportion. I can do the same thing here. Again, with 6/8 and 24/28, it might be easier just to use equivalent fractions and say, well, they are equal. They're both equal to 3/4 or 0.75. If I don't see that, I can go 6 times 28, again multiplying diagonally, and see, is that equal to 8 times 24? And when it's all said and done, we will find out that yes, they do both equal 168. Okay, and again, we might not need to use this with the particular fractions we have, but as we look at other examples, we might find it useful. So in this one, it's hard to multiply something real quick and easy by 15 to get to 16. So it's going to end up being 1 point something, some sort of decimal. So on this particular one, cross products is helpful. N times 16 is 16n. Okay, and on the other side, we're going to have 15 times 24. When we do that, 15 times 24 ends up being 360. So we have 16n equals 360. at this point it's just a river problem, and we get n is equal to 22.5. This next one, again, I could treat it as a river problem, multiply by n on each side, and make out a really long drawn-out process. I would avoid that and not use that in this instance. Again, I'd cross-multiply and go 3.2 times n is 3.2n, and then on the other side we have 4 times 2.6. And so we have 3.2n equals 10.4. And then if we divide by 3.2 on each side, divide by 3.2, we are left with n equals 3.25. Okay, and our next example, we can cross multiply again, and I'll go ahead and do the 6 times x minus 3. I'm going to write out this entire term here. And then we have 7 times 14. With the 6 times x minus 3, we need to remember to use the distributive property and get 6x minus 18. And then 7 times 14 is going to give us 98. At this point, again, it's a river problem. It's a two-step equation. We're adding 18 to both sides. And we'll have 6x equals 116. Divide by 6, divide by 6. And we get x equals 19.3 repeating. I'll give you a moment to take a look at that. I could also express this, if I wanted to, as a mixed number as well. Okay, word problems and proportions are often used as we look at, or proportions are often used in word problems. They're also used a lot if we're adjusting recipes and trying to either scale them up or scale them down. If we're doubling or tripling a recipe, or if we're cutting it in half. So here we have Trent on a 30-mile bike ride every Saturday. He rides a distance in 4 hours. At this rate, so using that same rate, how far can he go in 6 hours? So we know 30 miles in 4 hours. That's going to equal how far in 6 hours. And the how far we don't know. What's really important, I could set this up as 4 hours, 30 minutes also, and that's going to equal 6 hours. The important piece here is to get the labels across from each other. So if I have in the denominator and on one side, I need it in the denominator on the other, or vice versa if it's in the numerator. So we'll go ahead and erase that one. So I know in 6 hours he can, or 30 minutes, he can go 4 hours. But if we cross multiply, we end up with 180, and that's going to end up being 4x. We can go ahead and divide by 4, and we're left with x is going to equal 45. So how far could he ride in 6 hours? Something's not making sense here to me. No, that makes sense. Okay. Another way some people may tackle this is how far can he ride in 1 hour, and we divide by 4 and go 30 divided by 4. So again, a couple different ways to tackle this. Okay, so another turn for you guys. Go ahead, read through this, try it. Okay, so in this one, Isabella takes 7 minutes to go 2 laps. How far can she go in a half hour? And for the half hour, I went ahead and used 30 minutes. So we'll have 60 equals 7x. I can simply solve for 7 and end up with approximately 8.6 laps. I guess if we go to the hundreds, it's going to be 8.57. Okay, a ratio or rate that we call a scale is comparing the size of a model to the actual size. So it's the model or the fake to the real. So usually the fake number goes on top, the real number goes on underneath. And so here we have a scale of 2 inches to 9 miles. Okay, the distance between Discovery Point and Phantom Ship Overlooks, about 1 3/4 inches to D. We can go ahead and change this to 1.75 and substitute that if we want to use that, and go 1.75 times 9. That gives us 15.75 when we cross multiply equals 2D. Go ahead and divide by 2. Go ahead and divide by 2. And we end up with D equals 7.875. We could also convert that to a fraction if we wanted to and get 7 7/8. So go ahead and try this one on your own and hit pause, see how you do. So I set it up, we can cross multiply, and we get 5x equals 57, divide by 5, and we find that the wingspan is 11.4 meters. So that's it. Hopefully you guys are enjoying break, and we'll see you on Monday.